to see algebraic terms. So we have picked rectangles and squares for the visualization of algebraic terms. So algebraic terms involves variables. Variables are nothing but numbers that we don't know. So it is actually some numbers. So if it is x means it has some number. So if it is the term x means we can use it. We can show it using the rectangle. So one side is the x, another side is 1. So 1 times x is just x. So x is the small rectangle. So if it is a x squared term means, so both the side will be x and x. So x into x is x squared. So this is how we represent x squared. If there are two variables means, this side is x and the another side is y. So it is xy. Or if it is yx means, it will be this side will be y and this side will be x. But we know in multiplication, multiplication is commutative. So both xy and yx are same. So 1 into x or x into 1, everything is same. So this is how we are going to see algebraic terms. But for negative and positive terms, we are going to shade it with different colors. For now, we have chosen only 3 variables, x, y, and z. We are going to see the use it for 2 dimensions only. That is, the order of our equations will be only 2. Now we are not going for 3 dimensions. It is using only 2 dimensions. It means in a single term you can have either square or you can have 2 different variables, not a cube or a 3 different variables in a single term. So, and we are going to choose different colors and different length for x, y, and z. That we will show. The next backdrop. So here our x variable will be represented using this blue color line, and our y will be in the green color line, and the z will be in the pink color line. And for a one side, if it is a term of a single x or a y term, our one side will be 1 and the other side will be that variable. So for that we are going to use this one light blue. And for a positive term, we are going to shade that square or rectangle using the brown color. And for a negative term, we are going to shade this using a yellow color. So in the my blocks, there are already there. Shade rectangle. So in the length and breadth is actually what we are going to give is either we can give x, y, z or 1 for both length and breadth. So let's see for x length and for breadth y. And we are going to mention positive or negative using P or N. So what is a positive? So it's a brown shaded picture. So it is a positive term. And our length is x and our breadth is y. So blue color is x, green color is y. So that's how we are going to change. If you wish to change the color of the variables or the length of the variables, you can go to the list. Here. We created 3 lists that here in the x, y, z index, it is the name of the everything that we are going to use, x, y, z, and 1, p, n, positive and negative. Here in the color, we are given we set the numbers in the color x, y, z, 1, p, n. For if you have a question how the color works using the number, we have used the set pen color. If you click the color, there are 3 things: color, saturation, and brightness. We've set the brightness and the saturation to the 100, and we just pick the color using the numbers here. For a blue, it will show 70 something. And length, we have just given something 40, 65, 55, and 50. So it is put in the flag click block. So whenever we click the flag, all the variables will be, all the items will be set in the list. So we can just use the shade rectangle and code it. So for if you wonder how to do for 3x or 3x square, that we can use a repeat down rectangle or repeat left rectangle. So x and y are the positive the coordinates here, and for repeat is the coefficient of the terms. So for 3x, we can just give 3. So if it is just x terms with the length and breadth is 1 will be 1. One of them will be 1 and the breadth will be x. So if it is positive or negative, just mention it by p or n. So if I mention n, so let's see. Before that, we give the eraser. So this is the 3x. So our length is 1, breadth is x. It's shaded in the yellow color for the negative terms. So it is 3 times, so it is 3x. So if you give the same in here, 130, let's print the 2x squared. So our length will be x, our breadth will also be x. We are going to give positive term, so it's 2x squared. So we're given the same coordinates, it draws in the other. That you can actually, from this you can actually see that uh, x and x square are two different terms. So you can never say that x square plus x is a 2x or 2x square. So x is this rectangle, x square this square. So it is just x square minus 3x. From this you can form an equation. This is x 2x square, this minus 3x. So that's